on this place you need to think of even there's no other like integrity checks or reference checks or whatever. It's just a basic illustration. So let's have a deeper look technically. How does it work? Okay, so exploiting deserialization relies on built-in so-called magic methods, which are executed automatically. In PHP, for example, or PHP provides several of these for every object, like construct, destruct, sleep, and wake up, and other more. And for example, whenever in PHP we create a new object, we create a new instance, the magic method construct is fired or executed. Where the same we have for object destroyed, manually or by garbage collector, for example, then there's always a destruct method call. And for the serialization, so after the serialization process, the method sleep is fired up, and after deserialization, wake up is. So when you deserialize an object in memory, after automatically the wake up function is called. And normally in PHP for serialization and deserialization, these two methods on the bottom, serialize and unserialize, are used. So let's have a look here. We have an array, right? We're still in PHP world. We have an array with two elements, database with its various users, and the host with a local IP address. And if I try to serialize that array on my Kali machine, you can see I just call the PHP interpreter with the serialize function, and then I give the array. This is the result I got back. It's a human-readable serialized string. And the explanation I would like to say, it's we see that's a column-separated output, and we see this is an array, as stated here. This serial data is an array, right? And it's two elements in that array. We can see that the elements are wrapped in curly brackets and separated by a semicolon, as you can see here, right? And the first element key, which is it's this one, is a string with 8 characters of length, and its key name is it's database. And the first element value of the key is a string also with 5 characters in length with the value users, right? And this is true for the other elements. And this serialized object now can be sent over the network or stored in a database. Now I try to make a very simple application that we can, or it illustrates how it could be exploited, exploited in the end. So we have a PHP service here which is write log, which's purpose is just to create a log file in the temp folder while the deserializing process is in use. Sorry. And the service location, it's in var www.html log app. This is just a service we want to use in our main application to abuse in a later step. For my testing purposes, I created the serialized PHP application. As you can see here, I just include a reference to the service, to the write log service. And here I say log is a new write log. I create a new object of this service, and then I serialize. I equate and serialize this object. And if you can see on my Kali machine, I called it with the PHP serialized PHP, and that's the data result I got back. It's the same explanation the slide before, but now we see it's an object with 9 characters length and the name of the object and so on. But the important stuff here is the temp log file and the app in use values, because if we have go one slide back, you see this service has a file where it be located and the contents, right? And this is like how it looks like here when it's serialized. So in the next step, I created the index PHP, which is like an illustration of a vulnerable implementation of this write log service. You can see here I included the service again, and now I say data. I use the get superglobal to get the log from the request. That means I just get the serialized object somehow, and then I'm trying to unserialize it. So I want to deserialize it. And just the last echo state that I know it's initiated. And one thing I need to mention here is that especially like in property-oriented programming, POP, called POP, there's always the attackers or the researchers are looking for so-called gadgets. Gadgets that are like hops from entry points within the application code, because we as an attacker or as a researcher, we don't have control. We can't call the function right directly. We can only control the properties of the application code of this class, right? In this example, file and contents. And as it's stated here, our hope, or we rely on these magic methods I mentioned. They are fired up automatically once an object is created or destructed, for example, or deserialized in memory. And in this case, I want to write some malicious input of my property, but I don't have access to this write function. But I know that after this deserialization process, this magic method, wake up, is called automatically. So I'm trying to now, sorry, but this is called a hop. I wanted to say this is a gadget chain. It's a basic one, but technically is a hop. So now I just created, let's say, an exploit. In this case, it's a basic shell. I surrounded this with a password protection for me as an attacker or as a researcher, if you will. It just gives back a normal command back so that I can fire up commands on the system, and the password hash is the MD5 hash about this password I use. Here's write log test1. You can see the hash on my root Kali machine. So now this is the serialized evil payload I prepared. I want to send to this application, right? And the hope of when it gets deserialized, it triggers something malicious. So you can see that I replaced the values, because I control the properties of this application code, with something else. Like I say, the file content now is not temp anymore. It's now var, basically pointing to my shell in the log app, and the content is something malicious like my shell left in the end, my exploit, whatever it is. You need to adjust the range characters. If not, your payload will not work. This is very important. And here you can see we are using the commas. You need to escape as well, but you can see it when I use scroll to exploit it. And here locally I just fired up the PHP local server. Like it's the same like the Python HTTP server. And now it's like waiting for incoming requests. And this slide shows you that I am firing up a curl with the data URL encoded, and then you can see that I put the log and provide my evil payload escape, as I mentioned. Where is it? Yeah, it's escape in this. Yeah. After firing up, you can see I got the GET request on my PHP server, which was successful. It's at 200. Normally, if you have deserialization problems, you will see some errors regarding deserialized or unserialized functions. And the hope that we have a shell now pointing to that point. If I go to the browser, I hope you can see from there, but if you open the browser like shell PHP, and my password was the write log test1, and at the end it's very important because that's the command, the shell. I just provide it with ID, and I see, wow, it was successful, right? Now we have a shell on that system. It can be like whatever, cat ADC password or something malicious, or reverse shell, whatever it is in this. It's just for illustration here. It's really basic. But it shows you like, it shows you that if you don't check, like if you don't have validation checks properly, or integrity checks or signature checks on object level after the deserialization, that can lead to really serious problems. And now let's have a look at how we can detect this type of issues. So there are a few frameworks and libraries out there for different languages. I can't I can't like name everything, but just to name a few. There's this so-called Java Deserialization Scanner, which is a Burr plugin you can use for discovery and exploitation. It will help you in that process. There is a very, very, very famous and very good library called YSO Serial. I spent a lot of time in that library. It's an exploit helper and Java deserialization for Java deserialization vulnerabilities. And basically, it's a big collection of gadget chains for many different frameworks, open source frameworks, which are vulnerable to this type, like comments collections or being utilized, whatever it is. Then we have Serializer, which is a static bytecode analyzer for Java deserialization research. Then we have the Serialized Killer script, which can scan many servers in short time. And the last one is also a bit funny. It's a J-Infinity, which consumes all the memory of a target, which performs deserialization, and trying to brew it up. So maybe you can have a look. It's interesting. So now let's talk about how to prevent. First of all, your developer or developers in general, they should have security awareness training, because I have the feeling that even if developers know that they should do the user input validation right, in normal web application, when it comes to serialization, this is something maybe they never heard about, or they think it's very secure. But it's the same, because someone sends some data to you and you need to have a check on it. You can't trust. And that's the second one. Do not trust user input. I mean, really, never. Even in the form of serialized objects. And there is a very good cheat sheet from OWASP about deserialization, where it provides a lot of guidelines about white box testing and black box testing for different languages and frameworks. It's really good to have a look there. And